Hello everyone and welcome to this video on MCP architecture. This is the second video in the series, so let's get started. Prerequisite for this video is knowledge of MCP or Model Context Protocol. So if you do not know what MCP is all about, please refer to this overview tutorial that I had created some time back. The URL is mentioned right here at the bottom, as well as it will be mentioned in the description of this video. Now, in today's video, I'm only going to discuss MCP's architecture in detail. I will not be discussing about MCP's basics. So if you do not know what MCP is all about, please stop over here, watch this overview video, and then come back, because otherwise things further ahead might not make sense. So let's deep dive into MCP's architecture. Who are the key players for MCP's architecture? You have a MCP host, a MCP client, and a MCP server. MCP host typically an AI application that coordinates and manages one or multiple MCP clients. You also have a MCP client, which is a component that manages connections to MCP servers and obtains context from the MCP server for the MCP host to use. An MCP server itself is a program that provides context to MCP clients. So as you see, we have a MCP client, we have multiple servers, and this client is connecting to these two servers. Similarly, two clients and three servers. So this is simply some of the key players of the MCP architecture. Now let's look at layers. Layers form a critical part of the overall MCP architecture. Now, MCP consists of two layers. First is the data layer, and the second is transport layer. Transport layer is the outer layer, and data layer is the inner layer. So let's look at these two layers in detail. Transport layer defines the communication mechanisms and the channels that enable the data exchange between the clients and the servers. It includes any transport specific connection establishment, some kind of a message framing if that is required, and authorization. So let's say you have this client and you have this server. This communication that is established between this client and server is your transport layer. And of course, there's some kind of a messaging that happens, and authorization also happens between this client and server. The next is a data layer. So if you remember, MCP's core protocol is JSON-RPC 2.0. So data layer basically uses JSON-RPC 2.0 as one of its core protocols for client-server communication. So this transport layer has established a communication link between the client and the server. But what gets communicated over this is what is this data layer. Hence, this is the outer layer and this is the inner layer. This is what is transmitted by using the transport layer between the client and server. So this is, of course, again, a bidirectional communication. And this includes lifecycle management, some core primitives. Primitives are nothing but some very basic essential building blocks, such as tools, resources, prompts, notifications. So at a high level, this is what transport layer and data layer is all about. Now let's look at both of these layers in detail. Transport layer. Transport layer supports two transport mechanisms, stdio and streamable HTTP. Now let's look at stdio. STD is standard input output, right? So standard input output. That is what your stdio is. So standard input output. So uses standard input output streams for direct process communication between your local processes that are running on the same machine. So stdio is probably one of the best methods. It gives excellent performance because there is absolutely no network overhead. And the reason why it can give an excellent performance or one of the best performances is because it establishes process communication between local processes on the same machine. So if your client and server are running on the same machine, then that's where stdio will come into play. But that is not always the case, right? You could have a remote client and a remote server. Well, in that case, streamable HTTP is your answer. So streamable HTTP behind the scenes uses HTTP post. It can also use server sent events for streaming capabilities. Streamable HTTP, since it uses or it relies on HTTP posts, supports standard HTTP authentication. Of course, MCP by itself recommends OAuth. So now you can use HTTP post over here or streamable HTTP. Sorry, let me clear this. So you have a remote client and a remote server. And now you can use HTTP post or streamable HTTP for communication. So between any client and server, streamable HTTP can be used for client-server communication. Data layer. Now, data layer forms a core part of MCP because it defines the schema and the semantics between MCP clients and MCP servers. So you have different MCP clients, you have different MCP servers. Now, these clients want to connect with all these servers and vice versa, right? So in order for any client to be able to communicate with any server, a common schema needs to be established. And that's what this data layer enables. It also defines ways developers can share context from MCP servers to MCP clients. Of course, it uses JSON-RPC 2.0 protocol. Now, this layer behind the scenes includes lifecycle management. Lifecycle management for connections between clients and servers, and capability negotiation. It includes some primitives that defines what clients and servers can offer to each other. What are some of the basic building blocks or the basic services, some essential services that clients and servers can offer to each other? And finally, it includes notifications for any kind of real-time updates or progress tracking. Remember, notifications are one-way messages. That means a notification is only sent typically from the server to the client to inform that this is what has happened. When a notification is sent, no response is expected. It is just FYI. Now let's look at each one of these in detail. Lifecycle management. So we know that MCP is a stateful protocol and it requires lifecycle management. And in this lifecycle management, it manages connection initialization and termination between the clients and the servers effectively. So every time, a physical layer, of course, is created, but the client has to connect to the server. It has to open up a connection on the server. apart from the physical connection or logical connection has to be opened up. So that connection initialization and termination between the clients and the servers is managed by the data layer. What capabilities do these clients and servers basically expose or make it available to each other? So that capability negotiation also happens as part of the lifecycle management. Why is it part of the lifecycle management? Because capabilities can change. So you have to manage those capabilities effectively, just like how you have to manage a connection effectively. Server primitives or servers' essential building blocks. Now, these primitives specify the types of contextual information that can be shared with AI applications and the range of actions that can be performed. And some of the core server primitives are tools, resources, and prompts. Tools are nothing else but API calls, right? So basically executable functions that AI applications can invoke to perform an action. We have resources. These are data resources that provide contextual information to AI applications. Could be database records, could be file contents, could be anything else. And prompts are nothing but reusable templates that help structure interactions with the language models. And what servers basically provide are some few short examples of these prompts. So now let's take an example. Let's say you are creating a MCP server that provides context about a database. Now, how can you use tools, resources, and prompts? You can expose tools for querying the database, essentially API calls or database queries. You can use a resources to create a resource that contains the schema of the database, that provides some kind of information, contextual information. And you can use prompts to include few short examples for interacting with the tools. So now you see that when you created an MCP server, you can use tools, resources, and prompts effectively. Now, of course, this is not true for all the scenarios, but in most scenarios, yes, you will be able to use them. Now let us look at clients primitives or clients essential building blocks. Now, these primitives allow MCP authors to build richer interactions with their clients. The first one over here is sampling. Now, you should not get confused by this name. The sampling, as per me, is a misnomer. Okay, means that's not the right name. It shouldn't be called as sampling. Okay, this has nothing to do with sampling of data, sampling of records, or sampling of anything else. Yeah, if you want, you can typically say, hey, sampling of tokens because it deals with LLMs. But otherwise, sampling as per me is a misnomer. This should ideally be probably called as completion. Completion, because it is completion of some task that the server wants the LLM to do. Now, when is this sampling used? This is useful when server authors want to access a language model, but they want to stay model agnostic so that they don't have to include the language model's SDK in their server. So let's say you have clients, you have servers, and these servers want to remain LLM agnostic. So there's an LLM also over here, AI application. Now, this server does not really care what kind of LLM the application uses. It could be Meta, it could be Cloud, it could be Noah, or it could be anything else. It doesn't care. It doesn't want to even know what kind of LLM is being used. It wants to say LLM agnostic. I should be able to work with LLM, any LLM, but whosoever the LLM is. I should be able to communicate with that LLM and should be able to tell the LLM that, hey, this is what you need to perform. And that's where this sampling / complete method comes in. Basically, servers trigger this method to request and large language model, could be large language model, could be small language model, completion of any specific task. And this is LLM model, which is part of your client's AI application. So I want to remain agnostic of what or which LLM is being used. I do not care how the LLM accomplishes it. I don't want to take the overhead of how to work with a specific LLM. I don't want to include that LLM's SDK in my server because I want to remain agnostic. So I'm basically going to trigger something on the client so that it tells the LLM that, hey, complete this task or do this task. Typically, this is used by the servers to basically tell the LLM model that, hey, you need to complete this particular task. And hence I said that it should probably be named as completion, in my opinion. And sampling is a misnomer. Possibly they use sampling is because they were trying to sample and check if the LLM has finished its task by sampling some of its tokens. So that's why they use the word sampling. But otherwise, it is not sampling of any data or anything of that sort. You're not sampling anything like data or records or anything of that sort. So hopefully this sampling is clear. It can be absolutely confusing. When I learned it for the first time, I was like, oh my God, I don't understand this. Finally, I had to, dive deeper into it to understand what exactly sampling does. So hopefully this is clear. Now let us look at elicitation. Elicitation of a request basically is used by the server authors to request additional information from the user or ask for a confirmation of an action. It's very simple, pretty straightforward. And finally, we have logging. Logging is basically what enables the servers to send log messages to clients for debugging and monitoring purposes. So the last two are very easy. This is the one that you have to understand. Basically, it is to send a completion method or a completion signal or a completion message to the LLM model to complete that particular task. Let's look at notifications. So notifications are sent real time and they enable servers to inform clients about changes. So this could be any kind of changes, right? Now, when a notification is sent, remember that it's a one-way traffic. That means no response is expected. These typically enable servers to provide real-time updates to their connected clients and also provide real-time synchronization between the clients and the servers. So you typically have a server, you have a client, and the client sends a notification. The server sends a notification to the client. So it's a one-way traffic. No response is expected. So for example, a notification was sent or is sent by the server to its clients, basically informing its clients about the available tools change or certain tools becoming unavailable. So as the server is informing the client that I have a tool change. I have maybe a couple of new tools that I added. I have some of the old tools that are not available or are going to become available. So you have to make changes accordingly. So remember that this is a one-way traffic. No response is expected. So this client does not send any response to the server. That is not possible. That is not done. It's a one-way communication. So what the client does is client basically reacts over here by requesting an updated tool list. So you told me that, okay, your tools have changed. Some of the tools are going to become unavailable. So I am going to then, as a client, reach out to you and ask you for your tools list. So a client can react to the notification that is sent by the server, but there is no particular response that is expected by the server from the client when it sends out any real-time updates or notifications to that particular client. So I hope notifications is clear. So guys, we dived very deep into MCP's architecture. Hopefully this was helpful. Hopefully this made things clearer as to how this particular MCP protocol works. This is it from me today. Do post your comments. Do let me know about your experiences. If you are new to my channel, do like and subscribe. That basically motivates me to create additional videos. I try to create one video per week, basically sharing my knowledge with everyone. And I do this purely out of passion. Okay. I mean, I could have created a Udemy course. A lot of people actually tell me you should create a Udemy course. I might create one. But the intention was not to make money or anything. Intention was to just share knowledge with anyone who wants to learn. And sharing of knowledge typically should be done with nothing, expecting any kind of return. So it's a one-way notification from me to you. But the good part would be that you can react by learning or appreciating, so that I know that, okay, people are, liking my content, are following the content, and it's making a difference. That is what is the key over here, is to make a difference. So what I expect is basically, some word of mouth, or basically just some basic appreciation for all the effort that I put in. It's not easy, but I try. So this is it from me today. Thank you for watching this video. Do post your comments, and I will see you shortly. Till then, take care. Bye-bye.